All right, here we have note 6.3, dividing monomials. Okay, so to divide monomials, we use the quotient rule for exponents. Okay, and it shows here if you have an exponent with the same base, then you can combine it. You can combine these terms in the numerator by subtracting the exponents from each other. So x to the a over x to the b is the same as x to the a minus b. So let's do some practice problems with this. So number one, we have x to the fifth over x to the third. This could be rewritten as x to the 5 minus 3, which is x squared. Okay, as simple as that. Let's look at number 3 real quick. This is a special case. So we have m cubed over m cubed. We know since this is the same term, it should be equal to 1, but let's show it in exponent rule. So we have m to the 3 minus 3, which is m to the 0. And according to the zero exponent rule, any term raised to the 0 is equal to 1. Okay. Let's look at number 6. This has many terms in it. So we'll just look at the x's together, and then we'll look at the y's together, and then we can look at the z's together, okay? So this can be written as x to the 20 minus 5, y to the 9 minus 9, and z to the 2 minus 1. Okay, simplifying this is x to the 15th, y to the 0, and z to the 1st, which we know we can simplify. Y to the 0 is actually equal to 1, and z to the 1st can be written as just z. So this is x to the 15th. We'd be multiplying by 1 here, by this y term, but we don't write out when we're multiplied by 1, so then we'll just move over to z. So x to the 15th z. All right, so let's look at when we have coefficients. If we have coefficients in the numerator and in the denominator, we're going to treat them like their own fraction, and we're going to divide them, okay? And then we're going to simplify the variables with the quotient rule, which is what we just were working with. So looking at number 7 here, we're going to divide these coefficients first. So 6 divided by 2 is equal to 3, and then we're using the quotient rule for the variables here. So then we have x to the 4 minus 3, which is equal to x to the 1st, which we don't write. So this reduces to 3x. Let's look at a little more complicated one. We can just drop down below it. For number 10, we have negative 15 x to the 6 y to the 5th z over negative 3 x to the 5th y cubed. Okay, so a couple things to look at. We're going to look at dividing these numbers first. And just a side note, if we can't divide these into a whole number, like in number 7 and in this problem, we're just going to reduce this fraction as much as we can, okay? And then we'll do the x's together, the y's together, and then the z's just kind of hang out until the end there. Okay, so negative 15 divided by negative 3 is positive 5. Okay, we have x to the 6 in the top, x to the 5th in the bottom, so we're going to keep the same base, x, and then we're going to subtract 6 minus 5, which is 1. And we're just going to leave that as x. We're not going to write the exponent in. And then we have y. We have y to the 5th in the top, y to the 3rd in the bottom. We'll subtract 5 minus 3 is 2, so we get y squared. And then that z is just going to hang out there. So that is our final answer for this one. Okay, so try the rest of these on your own. And then this next section, and I think the rest of the notes is going to be mixed practice. But this mixed practice is mixed for all the exponent rules that we have done so far. So we'll have some powers of monomials, we'll have some multiplication, we'll have some division, possibly some adding and subtracting. Yeah, towards the bottom here, there's some adding and subtracting as well. So I'll pick out a couple problems to do together, and then you can do the rest on your own. So remember, we're always going to do these powers of monomials first before we do anything else. So this numerator here is now going to become 3 squared and then x to the 10th. So remember, if we have a power of a power, you're going to be multiplying those exponents together. And then the denominator is just going to stay the same. So simplifying here, we're going to calculate 3 squared, which is 9. 9x to the 10th over 27x cubed. We want to divide these coefficients here, and you can see that this doesn't divide to a whole number. So like I said earlier, we're going to just reduce a fraction, and it looks like both of these you can divide by 9. Okay, and that's going to equal, in the top, that'll equal 1, so we'll just leave x to the 10th here. And then 27 divided by 9 is 3, and then we have x to the 3rd. Now let's simplify using the quotient rule, where we have x to the 10 minus 3, which is 7, and then that 3 will just stay in the denominator like that. Good. Okay, let's look at let's look at number 17. There's a lot going on with this one. This one's really good. Okay, so we're going to do this power on the outside first. And remember, this is going to go to each of these terms on the numerator, and it will be going to each of the terms in the denominator. Okay, so let's rewrite that first. So we have 2 cubed up here, m to the 4 times 3, which is 12, n to the 2 times 3, which is 6. That's the numerator. And then we have 4 cubed in the denominator, m to the 2 times 3, which is 6, and then n to the 1 times 3, which is 3. Good. Let's just calculate these coefficients here that have been cubed. 2 cubed is 8. And then we keep m to the 12th, n to the 6th. And then denominator 4 cubed is 64. And then we have m to the 6th. Oops. Let's see, I miswrote this first one. This should be an n. M to the 6th, n cubed. And now let's simplify using the quotient rule, okay? Oh, let's back up a second. We do need to divide these out here as well. Okay, and it looks like we can divide both by 8, and that leaves us with 1 as a coefficient in the numerator, so we won't write it in. We have m to the 12th, n to the 6th. And then 64 divided by 8 is 8. Then we'll keep m to the 6th, n cubed. All right. Now let's subtract these exponents, okay? So we have m to the 12th in the top, m to the 6th in the bottom. So we're going to have m to the 12 minus 6, which is 6. And then n to the 6 minus 3, which is 3. And then we'll keep 8 in the denominator there. Awesome. Okay, let's look at... come down here. How about number 23? So, as usual, we're going to take care of these powers outside the parentheses first. This squared is going to go to the 2 and to the x cubed. This 3 is going to go to this 3 and to the y to the 4th. Okay, so let's rewrite this. In this first, we'll keep the parentheses for now. In this first one, we're going to have 2 squared, which is 4. And then x to the 3 times 2, which is 6, x to the 6th. And then in the second parentheses, we're going to have 3 cubed, which is 27. Y to the 4 times 3 is 12. And then the denominator for now is going to stay the same. Okay, so then let's multiply this numerator. So we have 4x to the 6 times 27y to the 12th. So let's simplify this. We'll multiply the coefficients together. So 4 times 27 is 108. And then that's all we can do. We only have x to the 6, one x and one y term. So those will keep their coefficients. And then our bottom will stay the same as well. Okay, now we're just dividing, so let's take care of these coefficients first. So 108 divided by 12 is equal to 9. So we'll keep 9 in the numerator. And then we have x to the 6th in the numerator, x to the 4th in the denominator. So we have x to the 6 minus 4, which is squared. And then y to the 12 minus 5, which is 7. So this whole thing is going to reduce to that answer there. Awesome. Let's do one more with a subtraction at the end. So let's look at number 27. Okay, so we're doing the exponents first as usual. So let's rewrite this. We have 2 cubed, which is 8, and then m squared raised to the 3rd power, so m to the 2 times 3 is 6. And then we have 3 cubed, which is 27. And then n to the 4 times 3 is 12. N to the 12th. Okay. The denominator stays the same. We're not doing anything with that yet. And then this whole term we can keep like that. All right. So now let's multiply. Oh, I'm in red now. I meant to be in blue. Now let's multiply this numerator here. Switch back to blue. So we'll multiply the coefficients. 8 times 27 is equal to 216. And then we'll keep m to the 6th, n to the 12th. That is all over 9, m to the 4th, n to the 7th. And then we still have this term that we're subtracting there at the end. So we want to reduce these, divide out these coefficients here. So 216 divided by 9 is equal to 24. Then we have m to the 6th over m to the 4th. So we have m to the 6 minus 4, which is 2. N to the 12 minus 7, which is 5. And then I'm running out of room here, but then we have this whole term minus 18m squared n to the 5th. And notice now, since we have done this, we have our like terms now. So we can just subtract our coefficients and keep the variables. So 24 minus 18 is equal to 6, and then we keep the variables m squared n to the 5th. And that is complete there. All right, so try these problems, the rest of these problems on your own, and then go ahead and try the homework. If you have questions, you can email me at any time. I'm always happy to help, and you can also ask me